For number one, we're looking at a histogram and deciding if it looks bell-shaped or not, because if it is bell-shaped, then a normal distribution could be used as a model for the variable. Looking at your textbook, there are some good pictures of how this would look in the chapter. Number two is going to be very similar to number one. Just look at the relative frequency distribution and decide if it has the shape of a normal curve or not. Number three is all about how to read and analyze and interpret a normal distribution. So when you have a picture of a normal distribution and you're seeing a shaded in region, that area that is shaded in, there's two different ways you can kind of think about it. That area has a value associated with it, and it's either the proportion of the entire population that fits into that range. And so for this, what I mean by that range in this example is being larger than a certain value, because we've shaded in the area larger than a certain value. So either the proportion of the population that fits into that range, or if you randomly selected one individual out of the population, what's the probability that they will fall within that range? Number four is about finding the area under the standard normal curve that lies to the left of certain z values. So anytime we have a normal distribution, we can find a z value, and that measures how far away a data value is from the mean, and it's all relative to how large the standard deviation is. So a z value, for example, of 0.77 means that the data value is 0.77 away from the mean. And 0.77 standard deviations away from the mean. Let me pull up and StatCrunch here. So if you go to Question Help StatCrunch, you can load StatCrunch. And if we go to our calculators, stat calculators, and then our normal distribution calculator. This gives a great illustration of what we're looking at here. So let me resize it a little bit. The area to the left of 0.77. So we want to click on standard here because we're just looking at one data value, and a mean of 0 and standard deviation of 1, that is standard normal curve. And so that means we're dealing with z values. So p less than or equal to, you would type in what you're looking for, 0.77, and then hit compute. And it gives you a visual illustration of what that means. It's the area one standard deviation above the mean would be right here, and we're only 0.77 above the mean, so we're not quite to 1, but it's all the area to the left of that. The probability that a randomly chosen individual falls within that shaded region is this value right here. And I'll do one more here with StatCrunch, the area to the left of the z value, negative 1.11. So negative 1.11, visually, we are just over one standard deviation away from the mean, but on the negative side, to the left of it. And so our shaded in region here, this area, the value of it is right here. And that's the probability that a randomly chosen individual would fall within that region. I do want to quickly show how to do these in Excel as well. If you have the standard normal distribution, and you have a z-score, Excel will quickly give you back the probability of being at that z-score or further to the left, like we have illustrated here in this picture. And the formula you use is written right here, equals norm.s.dist. The .s is for the standard normal distribution, which means our mean is 0, our standard deviation is 1. And basically, you're going to enter the z-score then. So open your parentheses, the z-score, comma true, close your parentheses. When you hit enter, it gives you back that probability of being at that given z value, the z-score, or even further to the left. Number 5 built off of number 4. Now we're looking at area under under the standard normal curve that is between two z-values. So first, to show in StatCrunch, if you click on between, and we have a mean 0 and standard deviation of 1 because we're dealing with our z-scores, standard normal distribution, you now have the option to enter two z-values. So negative 1.09 and positive 1.09. If we type those in and you hit compute, it gives you the illustration that we're looking at the area between those two z-scores and the probability that a randomly chosen data value would fall within that region. And again, you can use Excel to get that same value, use that same formula, but take the z-score that's further to the right and then subtract the z-score that's further to the left. So the 1.09, I entered that first in Excel and then subtract away the negative 1.09 because that z-value is further to the left. And doing that, and then number 6 builds off of 4 and 5. Here we're looking at area to the left of a certain z-value and also to the right of a certain z-value. So let me get back into StatCrunch here and just look at how to do this first part A here. Find the area under the normal curve to the left of z equals -2 plus the area under the normal curve to the right of z equals +2. So that one, if we understand the symmetry of the normal distribution, be on standard here, and we're going to the left of -2. By symmetry, the probability of being to the left of -2 is exactly the same as being to the right or above +2. And you can see that if you switch this to greater than a +2, that looks exactly the same as what we had with less than a -2. And so you can just calculate one of these and then double it. So if we double that value, we get the combined area of being either left of this z-value or to the right of its opposite z-value. For B, we actually get two different z-values, so we're going to have to find their probabilities individually and then add them together. So to the left of negative 1.51 z-value, negative 1.51, make sure you have less than here, so you can see by your picture that we're looking at the left of that z-value. So jot down the probability of being in that region. And then we're going to look at to the right of a z-value of 2.51. And so then you would jot down this z-value, this probability associated with this area, and add those two together to get the combined probability of being in either one of those two regions. And so to illustrate how to do a probability in Excel that gives you to the right of a certain z-value, you'll want to use that same formula we've been using, but Excel's only giving you to the left of a certain z-value. So if you want to find the probability on the right, you have to do 1 minus whatever Excel gives you for the answer to the left. So here I would do 1 minus the probability of being to the left of that z-value, and it gives me back the probability of being to the right of that z-value, like we see in the picture. For number 7, we're looking at more probabilities with the normal distribution, but now we're moving away from the standard normal distribution. We're having distributions with other means besides 0 and other standard deviations besides 1. So for this particular example we have here, we can still use the same calculator in StatCrunch. Just enter in the new mean and the new standard deviation. And then here we have x is greater than or equal to 40. So you want to make sure you're on greater than, you type in 40, you get the picture of what we're looking for. So our mean 50 is right in the middle. Our data value of 40 is off to its left, so the probability of being at 40 or greater, and it comes out to this value right here. Once again, show this in Excel. Now instead of norm.s.distribution, we just use norm.distribution.dist because we don't have the standard normal distribution. We have different values for the mean and the standard deviation. So enter in the data value you're looking at, the mean of the distribution, the standard deviation, and then comma true, close the parentheses, and you're going to get that same result as in StatCrunch. Now, as I mentioned earlier, since we're doing to the right of or greater than 40 for this example, we need to do 1 minus that in Excel because Excel only gives the probabilities back of being to the left of a certain value. So 1 minus that gives us that same answer back that we saw in StatCrunch. And I want to tie everything in together for what we've seen on the last few problems. If we look at this example I just did, the z-score for 40, we calculate that by doing 40 minus 50, see how far away it is from the mean, and divide by how big the standard deviation is. So 40 is this far below the mean in terms of z-score. So if we went back and entered our standard normal distribution, and we went back to doing our z-scores, we should get the same exact, I typed that in correctly, the same exact result. We're looking at the same exact situation here. If we look at the z-score and the standard normal distribution as we have when we look at the actual data value in its original distribution with the original mean and standard deviation. Number 8 is going to be very similar to 7, but it's in between here. So make sure you have the proper mean and standard deviation entered. And then you can enter the two data values here. We're actually using data values instead of z-values. And it'll give you the picture of what we're trying to find, the area between those two data values, and the probability that a randomly chosen data value falls within that region.